So, hello everyone. In this particular video, I'm going to tell you about the problem that is subset, your subset 2 problem. Now, basically, what does this problem state or what you have to do in this particular problem? So, what you have to do here in this particular problem is that you will be getting vector or a vector or an array which will be having something of this kind, like this will be your elements, and you will be doing here what? You will simply be doing here the method of generating the subsets such that you shouldn't have duplicates. If I just go on telling you what does it mean, like you have to generate, this is your given vector or an array, and you have to do what? You have to simply return all the subsets. You have to return all the subsets with no duplicates, with no duplicates. So this is the problem statement that you have been given a vector or an array. And this is an hypothetical example. You can take any one of them, or like you can take any other example as well. And you have to return the subsets of this particular given vector such that there are no duplicates. Now, I will be explaining you again this example, like what we have to do basically. Then we will moving on further. So this is your like, let me do it. Like this is your particular given vector. Like this is your given vector. Now, if you take for a particular element, just understand this, that if you take for a particular element, like if you take this one, then its one subset can be 1, 2 with this 2. Then another 2 is there, so its subset will be 1, 2. Its subset will be 1, 2 with this 2 as well. Then you have got two threes. So this will be 1, 3, and this will be another 1 3, because if you want to return the subsets of a particular element from a given vector, then you will start doing this, like for a particular element you will take it and you will do like this 1 2, this 1 2, this 1 2, and this 2 1 3. So is this, and along with, if you don't take any element, if you don't pick rather any element, then you will get an empty set. So if you just look upon it, then is this what you need? Like what, if you just count the z, then 1 2 3 4 5 and 6, you're getting 6 subsets. But is this what you need? So you have to return the subset of this particular given vector array such that there are no duplicates. Now, if you find here these two match, these three match. So is this the what you need? You simply don't need this. So what you will be doing here? You will simply, after you have picked 1 2 once, then you have to make ensure that you don't get this particular 2, as simple as. Like you shouldn't get 1 2 again. It is a subset. 1 2 is a subset. But remember this, when the condition is given that you shouldn't be having duplicates, then 1 2 again can't come. You can pick like this 1 2 and 2. This can be your subset, but you can't pick 1 2 again. Similarly, if you pick like this 1 2 2, then you have another option of coming 1 2 2 again, because you have got 3 2. You can't pick it like that. As simple as that. Similarly goes for 3. 1, 3 can only come once, and 1, 3, 3 can come, but 1, 3, 3 can't come again. So this is the meaning of duplicate. Like you have to return all the possible subsets such that there are no duplicates. So 1, 2 will come once, 1, 3 will come once, and similarly 1, 2, 2 will come once, and 1, 3, 3 will come once along with your empty set. Like all other elements will also come from 2 as well, it will come. So it is just that. Now, next approach is our making a recursion tree. Next approaches are recursion tree, as simple as that. So what we are doing here. Now, initially, if I just go and just tell you, like initially you have got a particular index and you have got a particular data structure in which you will temporarily store that particular subset. So suppose this is your data structure. This is fine. This is your index. Now, if your vector was this, like 1, 2, 2, and this one, this 2 and 3 and 3, then you can start from this index as well. You can start from this index as well. You can start from this index, this index, this index. As simple as that. So, so now you will be doing your what? Now, what I said, when you will be going through or when you will be making a recursion tree, then what will happen? You will first be taking the starting index. Now, starting index that will be a particular for a given vector, like from which index you have to start. And this will be a data structure which will be temporarily storing the subset before finally you will push it into an vector of vector and which will return all the subsets. So, like here, I will, as I've started with 1, you just simply see, as I started with 1, so initially index will be at which position? Initially index will be at this 1 position. Now, so, or sorry, this is not 1 position, this is the 0th index. So the index is what? This particular index is your 0th index. So as I move, so initially the index will be 0. So I will be just erasing all this. So now we will be making the recursion tree. So initially the index will be your 0, and here will be a particular vector. So vector is normally denoted by the letter V, so I'm taking it with V. So this is your initial data structure. Now, when you are iterating it again for your next index, so you know that you can only pick each element once, that you know that you can pick each element once. So next time you will move to the next index. So this will obviously come to 1, and so initially, if you are at the 0th index, then you have got the data structure as 1, as simple as that. If you pick it. So if you pick it, then you have got the index, like you were at the 0th index starting and you took it, like you took the 0th element, 0th index element. So now your data structure, that is V, has got the element 1 inside it. Now you moved on to the next index because you have to take each element once. Now here is the possibility. You will try to find out all the possible cases. So now you have picked the 0th element firstly. First, we will take into consideration that we were at the 0th index and we took the 0th index element inside the data structure, that was vector P. Now we moved on to the next index, so that is 1. And can we take the next element? Answer is yes. So we got updated. As simple as that. So now your V has got like 1 and 2. Now the next possibility is like that you are on the one index, like you are on the one index, and can you take 1 and 2 again? Can you take? You can't. As simple as. So this probability will not be there because it won't be there. Why? Because you have already got 1 and 2. So you can't actually take 1 and 2 again. Next index. As simple as that. Suppose if you don't pick this. As simple as that. Suppose if you don't pick this, then you can't actually go to this particular index. That is your 2. So if you don't pick this, suppose I took 1 and I never wanted to pick the first index element because after 0, the pointer will move to the next index. And suppose I never wanted to pick the number placed at index 1. So I came to place index 2. Can index 2 be there? No. And can index 3 be there? Like this particular case. Can index 3 be there? 1 and 2 again. No. As simple as that. The reason being is that you have already got 1 and 2 once. Just understand this. You have already got 1 and 2 once. So next time, if you don't want to take duplicates, as mentioned in the question, you won't actually like take this possibility into consideration where you are again actually taking 1 and 2. This and this will return you the same result as it was returning this. So you can't take these two elements. So you will move on to which? You will move on to the element that is 3. Because at this particular index, you have to create the particular data structure because the number of elements you can push at a time will be 1. So at this particular stage, you will only be creating here what you call as the vector or your data structure of size 2. As simple as that. This is what it is all about. So now we will be moving to another structure like at this particular place, can we take another index like your 1 comma or your 3 is at which index? If I just write here the index, so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So 3 is placed at the fourth index. We can't take the element before, so we have reached here 4. Can we take 1 comma 3? We can take simply. We can take. Like if we have taken 1 comma 2 once, then we can't actually consider. We don't have to consider the possibility of 1 comma 2 again because that will return the subset which will be the duplicate. So like 4 and 4 will mean what? That your data structure has got simply 1 comma 3. What I discussed here. Like you have got 1 comma 2, you have taken the possibility of 1 comma 3. Now in these both the subsets, that is 1 comma 2 and 1 comma 3, the size of the vector as of now is 2. So you are actually the stage where you are taking into consideration the subsets of size 2. So this is the case. Now can I take 1 comma 3 again, that is index 5 comma v? The answer is simply no, because you don't want to consider the subset again and you've already taken the possibility of 1 comma 3, so you won't take the possibility of 1 comma 3 again. So at this particular stage you have got the subsets like 1 comma 2 and 1 comma, sorry, the this will be at this particular stage you have got the two subsets, that is your 1 comma 2 and this is your 1 comma 3. Now, in order to decide for the base case and backtrack as well, what you have to do here, you notice that at a point where we have reached the index, last index, at a point where we have reached the last index, we have to do simply what? We have to simply take into account the fact that our recursion should stop. And this is the place like simply we have to run a loop kind of thing till the size. or less than size that you normally do. This is the case. So now, how to decide for the base case? As simple as now, how we will be deciding for the base case is as simple. Like you started from zero and you went on till five. That is in size minus one. For to get the subsets for this particular stage. Stage is what that you have to take the subsets of size 2, then size 3, and then so on. That will be a case. As simple as that. So you took it like this. And so for each and every stage, you will be going till what? For each and every stage, you will starting from 0 and you will be running till n. That is n minus 1, less than n. This is that clear? Like what will happen? Initially, when you were at one, that is at the zeroth index, you went till five to check the possibility. So when you are here, you will be going till this particular index. And when you are here, you will again go till this particular index. So what does that mean? That you have to run a loop here that is from your starting index, from where you are starting till n, or you can call here as n minus 1 is as simple. This will decide your base case. And as soon as you reach this particular index, you will simply push back that data structure, that is your temporary data structure, which is holding the subset for that moment. You will push it into your vector that will be returning all the subsets which are not having duplicates. So now comes the case. Let us move to this point. Like now you have reached at what stage? You were simply at the index, any of the index if you are taking, suppose if you're taking any of the index, suppose I was at the index, as simple as that, I was at the index 1. Let's see. I was at the index 1, comma v. And 1, comma v simply means what? 1, comma v means simply that you are holding the data structure 1, comma 2. As simple as that. So 1, comma v will take you to the which stage? It will take you to the another stage, that is 2, comma v. Now 2 comma v has the option that if you pick this element, then your v will become your data structure that is temporarily holding the element. It will become 1 comma 2 comma 2. Now again the same case comes. Can you take the consider the possibility of 3 comma v, that is the index, that when your index is at the third position and you are simply taking into account that you are picking this element, that is whatever placed at the third index. So what will this become again? This will again become 1 comma 2 comma 2. So are you supposed to take this? No. So this is not the possibility. So you have got another case, that is you have can come here at 4 and you can pick up the third element. Again, you will not pick up the third element similarly. So again, if I tell you the last kind of recursion, like what will go on. So if you reach this particular index, like 2 comma v, now your V as of now is holding what? Your V as of now is holding 1 comma 2 comma 2. So if you reach here F3 comma V, can you consider this element? You can. The reason being is that the size will now change. These are not the duplicates. These are not the repetitions. These are simply what you call, they are the new subsets because your size is increasing. 1 comma 2 comma 2 comma 2. This will be your subset for this. Now again, can you take the next element that is fourth? Yes, you can. Can you take the next element that is your fifth? You can't. Remember this. You can't. Fifth one you can't take. Similarly, you will move on. Now, what happened just I am telling you here. Now suppose I took the fourth element. That is 4 comma b. Suppose I took this element here because 4 comma b I can take that at this particular stage. I can take 1 comma 3. So what happens next stage? Now next stage, if I have taken that element, then what I will do? I will simply move on to the next, that is the fifth. And can I take Like, can I take the 3 again? Yes. Why we can take, like, 1 comma 3 is different from 1 comma 3 comma 3. So this stage will give you this. Now how you will give it? You will be reaching the fifth index. Remember this, you will be reaching the fifth index, which is the last index of your given vector. So you will simply push this particular data structure into what you call as simply the particular vector that will be vector of vector, which will be actually finally returning all the subsets. Now comes the concept of your time complexity, and you simply call as your space complexity. So time complexity, like, firstly, we have been, like, as we reach the end of the given vector, we are simply pushing this particular your vector v into a final vector which will be returning it. So you must be getting that particular end here. Now, next time, you are finding here that here for a particular index or for a particular value, there are number of options here. Commonly two, you can call commonly two, but here are for this particular value, that is f2 comma b. Here are number of indexes here. As simple as that. Here are what? Here are number of indexes. So what will happen simply is that you are finding for that n numbers, like for this particular r, for the number of elements given in an array. So, or a vector. So here the number of elements given in a vector was 6. So here our number n is equal to 6. Now suppose there was a vector of n elements. So what will be its time complexity? So simply it will be big O of n into 2 to the power n. Your space complexity will be what? The number of subsets for a given vector is normally 2 to the power 1. So space complexity. Now, the number of subsets for a given vector of n size will be simply 2 to the power n. These are number of vectors. Remember, space. Space is the amount of space that your particular program requires, and which is quite affected by arrays and all. So here are the number of subsets. Now, if you take that each of the subset is average length is particularly k or k dash, if you take simply, then this will be your space complexity. And finally comes another term which you must be knowing is your auxiliary space, which will simply be, now if you just find the number of recursion calls that are being made. So every time you just find that whenever we are at particular index, we are going, we are going till what? We are going till the last. So number of recursion calls that are being made here are simply equal to the number of elements in an array. So this is simply your auxiliary space will be big O of n. That is simply defined by the number of recursion calls that are being made. So we straight away move to the code. So this is the particular code for this particular problem. Now what I have done here, just simply see. I have created a function find subsets. Now this is what this function is simply doing. It is actually finding the subset, and when you are reaching the end, like when particular for a particular n size vector, it is reaching the last index. It is simply pushing back this particular ds. This ds is actually holding the value temporarily, and it is simply pushing the vector finally into the vector of vector, which will be actually returning all the subsets. Now, what I have done here, as I told you, you have to go for finding each and every subset. You will be starting from that particular index, and you have to go till the last. So that is clearly defined by this, and just like leave it as of now. So what happens? So I just mentioned here as of now, but I will be telling you as simple as this. Now, you started from the index 0 and you have to go till 5. That is clear. Now, what you are doing, you are initially, if you are picking that element, you are initially pushing back into a temporary data structure. And the next step you are doing what you are actually moving on to the next index. As simple as that. It is what it is, clear. You are simply actually taking that element. Suppose I took the 0th element and simply I did what? I simply incremented it, and then I will be coming to the next index. As simple as 1. Now 1 will be doing here what? Just remember, I have to go to 1. Now the case here comes. I will be pushing. Suppose this particular condition now you will find. I have pushed back this element. Initially 1 was there, now 2 comes. Now we move to another index, that is your 3. Now, for this particular value, remember, till the time this particular data structure has been pushed back, remember this, till the time this particular data structure has been pushed back, you can't simply, remember this, you can't simply actually check for the condition that it will not affect the duplicate one. So what you are doing? You were at the 0th index, this condition never came true, you push back the element and one gone into the data structure Ds. Then what happened? You recursively moved on to the next index. Next index, you will take into account what? You will go to 1. 1 has got 2. Okay. And 2 will be pushed back into this. Now, when you will come to this 3, so 3 is not equal to simply, now see, understand this. What you will check here? You have to just simply do what? Just understand this. Your I value has been incremented and j value, as simple as like what you have to find here, simple, that till the time your data structure is not pushed back, you will be checking this condition. Like this condition, what it means, I'm just telling you simply. Like this was your condition, and your jth element, like j is simply equal to here the starting index, and your indexes keep on actually incrementing. As simple as what? Remember this. Your index is keep on incrementing. So what you will be doing here, you will be checking that for an instance, if the value till the time I haven't pushed back. So when you have pushed back, then you will be go checking for, or you will finding the subset for another size. So for that particular index, you will be finding that if the number at this particular index was same or was equal to the number at the previous index, you are checking. Like for this, for index 2, the value is 2, and for index, the value is 2. So you will avoid that. So in this manner, you will be checking. Again, you will be checking for this particular stage, then index at 3 is same as 2. For index at 5, the index is same as 3. 4. So in this manner, you will be avoiding the duplicate. And as simple as that. So this is the method. And finally, suppose when the element will be doing backtracking, so you have to simply pop back it. Otherwise, it will do what? Now, suppose if I backtrack it, then 1 comma 3 should be reduced. As simple as that. Suppose if I just go to this particular index, then here simply if you, because at this particular index I picked this element, so when I am backtracking, when the function is backtracking, then I have to pop this element in order to get it again to 1 comma 3. As simple as that. So I am using the function pop back. This particular function will have your time complexity big O of n. And finally I'm doing here what? I am actually taking here a particular vector. I'm actually taking here a particular vector, and I will be taking here some more elements like 3 comma 3. And let- so I have sorted this particular vector. Now, sorted why? Sorted because now remember, sorting always simply does what? Sorting always takes into account the time complexity as big O of n log n. So n log n is always less than n 2 to the power n. So it is obvious the time complexity will be that what I've told you. So sorting does what? It will return you the subsets in a particular order. Calling the member of the class, this particular vector is a vector of vector. This particular data structure will hold the subsets temporarily. Calling the function, and this is the method to just simply print the vector. This is the method to print the nested vector. So as simple as that. Let us run this code. So you will be getting the answer for that as simple as that. What is happening here? So the problem for which the error was being generated was that while I was entering the elements, I actually used inside an integer vector, I just actually took space. So if I run this program again, you will find the number of subsets and you will actually notice one particular thing as well. Now, these are the number of subsets. Now you will be finding here the number of subsets are quite large. That is because it will be 2 to the power n. Now you found here that one has come and here an empty set is also being displayed here. Remember this. And here an empty set is also being displayed. Then one came. Then 1 comma 2 come. 1 comma 2 come never again. It never came again. You got 1 comma 2 comma 2. You got 1 comma 2 comma 2 never came again. 1 comma 2 comma 2 comma 2. Like sizes, numbers are being repeated, but when the size is changing, in particular subset, 1 comma 2 is not coming again. So this is a method to avoid the duplicate. And this was all about this particular program. So just remember this is the condition. Now, this is what you can simply avoid it. Like you will be checking that if our index, like every time your I is moving, so value of I is keep on changing. But you have to take into account the value j, as simple as that. So j will be at is equal to I, and I is equal to I plus 1, as simple as that. So j is not equal to I. You have to take into account. So if you just simply dry run this, so initially j is equal to I. So initially I was at 0, so j is also equal to 0. Then you just took it, j not equal to, so both are equal. So this condition got false. So what you will take into account? Then this I will come at equal to 1, as simple as that. Then this I will come equal to 1. Then you will check for this particular condition again. So this condition will simply mean what? This condition will simply mean like you will be checking for this I. So now j has not been equal to I. So what it happens? It simply happens like this, that this particular element now will be checked, as simple as that. So is this condition true? This is true, but this is not true. So this will run for particular condition where duplicates will come. So this is all for this video. So hoping that you understood this particular problem. Thanks for watching. Do like, share, and subscribe. Thanks all for watching.